So we will take a look at longest common substring problem. And we want to find out longest common substring length of two strings. From these strings, if we really see what is the answer, what is the longest common substring of both, what is the length as an answer?
3.
3. So that will be this ing and ing. So answer is 3. Now the point is, how do we kind of formulate this problem in terms of sub problems and kind of bring it to the recurrence for DP. We know this is a DP problem. So first of all, in order to define recurrence, all we have to see is how do we come up with the state of it, the DP state. So we want to find LCS length. So we want L substring length. For short, I will call it LCS length. If we want to get this length, what should be our parameters?
Length of both the strings.
Length of both the strings. So that is one option that we can go with. Length of S and length of
T.
This is one way usually we solve problems. We consider lengths into our equation. Second option that we use is, rather than using lengths, what do we use? If we do not use lengths of the strings, then we use
indices.
Indices. And indices also are of the two form. We want to
Start
take
index.
Start or end index. So if we take start index of S and start index of
T.
Start index of T. Or third option that we explore or that we go ahead with is usually end index of S and end index of T. Now, majority of time when we are solving substring kind of problems, like earlier we have done Kadane's algorithm and all. So in substring kind of problem, I would suggest like more appropriate things are going with indices, start index or end index, rather than going with basically lengths. So if we go with that, we will choose one of these two below two. So you choose whichever you want to go ahead with.
Let's go ahead with start index.
Start index. Okay, so this is the state we are choosing, and according to that state we will define our recurrence. For this state, it is important we define what this state is actually representing. So for this state, I will say if we are considering start index of S as this, that means we will consider only those substrings which are starting at this index and including this index, similar to exactly Kadane. And same way for start index of T also, we will choose, if we choose one index as a start index, that means that index should be included in our substring. Okay, so if we go with this representation, I will say this is representing longest common substring of S and T such that S starts at start index of S and T starts at
Start index of T.
start index of T. Now let's try to digest this, what this is actually meaning. So if we have to go ahead with this interpretation, that means if I write indices here like 0, 1, 2, 3, 4, 5, these are start indices of S. 0, 1, 2, 3, 4, these are start indices of T. So if at any moment I ask you, give me LCS length of, where I take start index of S as 2 and start index of T as 3, if I take this just to understand our state better, that means I'm considering start index of S to be 2. That means in S we are considering which string? Your start index of S is 2. Which string of S we are considering?
ing
0.
0.
And I'll say end can be anything. It can represent only I, it can represent only in, it can represent only ing or ing0. At least all of them satisfy our 2 to be the start index of S. Okay, same way, if we take 3 as start index of T, then which strings are we considering?
We can have G or GS.
GS. Out of all of these, we are talking about whichever is the longest common substring length of them, that would be the answer. So now if I ask you, out of all these strings and all those strings, do you see any common substring
No.
with both included? Answer is no. So this answer is going to remain as
0.
0. Okay. So this is our thought process for defining this state. Now we will go clearly and try to kind of analyze how do we split it up into sub problems. Okay, so now let's consider that you have two strings, and in order to generalize, if this is start of S, start index of S, and S is ideally stretched from here, we are just picking it to define transitions. It's always good idea to go with a generic start index, and this is start index of T. Now since we are talking about every string to be start index, that means first the base case of this would be, it will be from right side or from left side. What thing we can answer first?
Right side.
Right side, because if the 0 is the start index, it is the smallest string we are talking about. If 4 is, sorry, if fifth index is the start index, we can fill the answer. If 4 is the start index, we can fill the answer. That means when we are defining state for these two, their sub problems are to the right side. Okay, so there are sub problems on the right side. That means in order to define our recurrence with start index of S, start index of T, we can assume that all the answers of the right side are known to us.
Okay.
Okay, they will be used to define our recurrence. So there are two possibilities when you are looking at start index of S and start index of T, and both should be included also in the substring. So there are two possibilities. Let's go with LCS length of, for short, I'm going to call it as start of S and start index of T. This will be helpful.
Sure.
Now, let's compare the characters here. If we compare this character and this character, what are the possibilities?
It may match or it may not match.
It may match or it may not match. If it matches, what will be the answer? Let's say these characters match.
1 plus
So this 1 is common plus
LCS length of
LCS length of
SS plus 1,
SS plus 1
ST plus 1.
and ST plus 1. No doubt about this, right?
Right.
Yeah, because whatever is the common length of these, that will be the answer. So this case is defined, and this is applicable only when the characters match. So if S of SS is equal to T of TS,
ST.
T of ST, sorry. Okay, but what if they don't match? So this case was clear. What if they do not match?
Then we may want to increase the start index of 1.
No, we will not do that. That is where we will deviate from our definition. Just see, we said we want to find longest common substring of SNT where ST must start from here and T must start from here. That means you cannot skip these characters.
Okay.
If you cannot skip these characters, if they are not common, for example, here you saw it was starting from I, and I cannot match with G.
Correct.
Okay, so if that be the case, if their first characters itself are not matching, what will be their common substring? 0, it will be. Yes, so this will be 0 if S of SS is not equal to T of ST. Now, this is where we have to be extra cautious because this start is fixed in our definition. If we start jumping, that means we are going to the subsequence problem. It doesn't remain substring problem. For example, in our string, there was something common also. Let's say we are talking about RIN and IN.
Correct.
Okay, if we take RIN and IN, first string is RIN and second string you are fixing to I as the start string. If you fix them like this, now if I ask you between these two strings where starts are fixed, calculate the subcommon substring. So you will not jump and compare this here. You will compare them as it is, their positions are fixed, and now you are telling their substring with every characters matching. Here your answer is going to be, if this is your start,
Zero.
this will remain zero. So we will not try to match this I with that.
Okay.
Later on we will see. You may say, currently you may say, hey, but for these two strings, my answer is two. There is two common.
Right.
But according to our definition, this state is not directly giving us the answer. This
Sure.
state will give something using which we will come up with the answer.
Okay.
Okay, so this state is right now saying if you have first string, second string written beneath each other and their starts are fixed and you are comparing them character by character, how much longest common substring you can find.
Okay.
Okay, so this is crucial for us to understand here. Okay, so once this definition is formed, once this formulation is done, let's try to analyze what eventually we are going to get for this string. So can I say, since we have defined in terms of two parameters, can I say we will have answer for every subproblem?
Right.
So can I say that we can represent it like a 2D just to understand things better? Let's create it like a 2D where S I'm taking on this side and S has indices 0, 1, 2, 3, 4, 5 and T you are having as columns 0, 1, 2, 3, 4. According to our definition, if we go just randomly, if we define, imagine if S has 2 as starting index and T has 1 as starting index,
Okay.
then what is the, you compare ing0 and ings. Now compare these two. What is the length that is going to be there? Common substring length, manually just see.
3.
3. So basically in this matrix or in this state table, what we are going to say is at S2 and T1, we are going to have the answer as 3. This is what is the meaning.
Okay.
Okay. And if this,
Because we are considering all the substrings starting from that position, right? So ing 0, ing s, ing, ing,
correct.
I. That's how we are calculating.
Yes, and that too we are fixing them kind of positionally, one below another.
Okay.
But if you compare same thing, ing with ring, ing starts at 2, this starts at 0. So that means if you are filling 2 and 0, because their first characters do not match, you are simply going to say, hey, it is 0.
Right.
Okay. So this is the kind of idea about how we have defined our recurrence. And it is pretty straightforward recurrence, that this recurrence is only thing it is going to tell us is if start indices I give you as fixed, compare them character by character and get me the answer.
Yes.
Okay. So let's quickly fill it manually for now to understand things better. So if start index is 0 of S and for T the start index is changing. If T start index is this,
Then it's 0,
0,
0, 0, 0.
because it doesn't match, so you will be 0. Now if S I fix at index E,
Then also it will remain 0.
okay, because there is no E, no match here.
Correct.
Okay, then if we fix it I, if S is at 2 T is at 0, we have filled it 0 already. They are not
Right.
matching. If S is at 2 and T is at 1, we saw it was 3.
Okay.
Okay, manually we are filling. We are not using our recurrence for now. If S is at 2 and T is at 2, then this is I and
0.
this will be 0. Okay, if S is at 2 and this is at G,
0.
this is also 0. Okay, now move this to 3. If S is at 3, for 0 and 1 it will be 0, 0.
Right.
And for next it will be,
2.
so this is at N. Yeah, so 2 it is matching to character, so it will be 2. Next, so this is at 3, which is this, and this is at 4. Sorry, this is at 3. This is N and G. This will be 0.
Right.
This will also be 0. Okay, now come to 4. When this is at G, G does not match first 3. So first 3 will be 0. This G matches this G.
One length.
This is one length. And then G doesn't match S. So this will
0.
be 0. Last,
All should be 0.
all should be 0. So if you just look at these answers, we have ideally solved every subproblem. If you look at these answers are saying with every index fixed as a start index, what answer we are getting. So now if I ask you, with every realignment of SNT, every adjustment of SNT, we have filled some answer. Out of these answers, which answer will you pick to be your answer?
3.
3. And what are the basis of that?
Because it's asked the longest common substring.
So maximum in this would be our answer. So now coming back, defining, here we came with our two cases and we said maximum of all LCS length with SS and ST will be our answer, where SS varies from
0 to,
S length minus 1
right,
and ST varies from
0 to
T
T
length
length
minus.
minus 1.
Okay, so this is our state is defined, our transition is defined. This is giving some sort of answer to us, 0 or this answer. And then out of all the states, we are looking for maximum. So this will eventually help us solve the problem. Okay.
Right.
Now let's apply this recurrence and see like how we will be actually filling our table using this recurrence, and then we will match whether it matches our manual table or not. Okay, so our strings I need, it is being 0 is S and T was
Ring.
rings. It was ring or
Rings.
rings? It was rings. Now looking at this, which cases are easy to fill in our table? Zero, 1, 2, 3, 4, and 5. 0, 1, 2, 3, 4. We did not define recurrence we defined, but we did not define base cases. Let's define base cases also. What is the smallest substring that we can compare of S and T?
One length.
One length. And since they are start indices, so for S, that start index should be in this S of S length minus 1. So we can say LCS length of, if start index of this is string length minus 1 and whatever is ST doesn't matter. T start index can be anything, but if this is the start index of S, then the answer can be
1 or 0.
1 or 0. It will be 1 if
the character at S length minus 1 is same as character at ST.
Absolutely, if there is a match. It will be 0 if there is
no match.
No match. So remember, like we will be having comparison from the right side. Okay.
similar case we will consider as base case when in the string T we are putting T length minus 1.
Correct. If there is a match, the answer is 1. If there is no match, answer is 0. Okay.
Okay.
So let's go now. We know that we can fill the last row and last column easily.
Right.
So when we are filling the last row, okay,
Okay.
that means in S we are fixed to
0.
0. Now keep comparing that with characters of T and fill this row easily.
So everything will be 0.
Everything will be 0. Same way, take S and compare that with every character of S string.
Everything will be 0.
Everything will be 0. So basically the base case filling is done.
Okay.
Now, in order to fill remaining cases, we have to look at their corresponding characters. Now, usually it becomes easy when we write characters also on top. Comparison will start becoming easily visible. This is rings. This is
Being 0.
being and 0. Let's see now. Now, when you are comparing, so your comparison will start from backside, right?
Okay.
So now you compare fourth and third character. Here it is G, here it is G. They are same.
Right.
We said if the characters match, if they are same, we will say 1 plus the answer of these two. Current is 4, this is 3. So the answer that you fill here will be 1 plus answer of
4.
4 and 5.
Right.
Okay, which means this element is a diagonal element. You will add 1 to it and store here.
Okay.
Is that fair? So we fill 1 here.
Okay.
Okay. Now compare fourth character here and second character here. This is G, this is N.
No match.
No match. So directly fill 0. This case. Next, compare G with I.
0.
Next, compare G with R.
0.
Okay. Come back. Compare N with G here. No match. Fill 0. N with N here. There is a match. We said if there is a match, what we will do? We'll add 1 to this diagonal element and store that here. Okay. Now this recurrence is helping us. Now compare N and I. Doesn't match 0. N and R doesn't match 0. Come up. I and G no match. Fill 0. I and N no match. Fill 0. I and I match. So fill 3. Now I and R no match. Fill 0. Same way E, G no match. E, N no match. E, I no match. E, R no match. B, G no match. No match. No match. No match. At the time of filling this table, if we can also, whenever we are operating any cell value, if we can keep track of max value,
Right.
we will be done.
Correct.
Okay, and look at this table and look at the manually filled table. Was it
These are
same?
same.
So, so this validates that our recursive formulation is actually leading us to correct answer. With only extra thing defined is this recurrence is not giving direct answer. And if you remember in Kadane algorithm also, we never used to get direct answer. We used to find the maximum in the array. So this is something that is tricky in this problem. So, so where is our answer? Is kind of max
All the values.
of all the states.
Right.
Okay, and in thinking all this, we chose the start index to be the representation. Now, as an exercise, you can think and define your recurrence with every index as end index. That would give you a good practice. So this is, and it can be solved with an index also. So this is LCS. Next, we will talk about their top-down code as well as bottom-up code using what we have discussed. Okay, so we'll stop this approach here.